so this is a review from Algebra 2, but we need it for some of the things going forward, so that's why this is just like a straight up review. Before we get to the actual polynomial long division, we are going to start with old school elementary long division, and let's look at number 2. So the numbers on here make no sense, but it doesn't really matter. So we are going to divide. Okay, so don't get ahead of me because there's some things I want to point out on this. Hopefully you can divide this. I think that y'all do have these skills. But we're going to take 13 and we're going to divide it into 5,467. Right? So we know which one goes on the inside, which one goes on the outside. So we first look at, all right, I want to take 13 into 5. Well, 13 doesn't go into 5, obviously. So 13 into 54 then. So let's see, 3 would be 39. Let's go with 4 maybe. So we'll put 4 in, but it goes above the 4. It doesn't go above the 5 because we're dividing it into the 54. Make sense? Like that's why you do those things. So 4 times 13 is 52. Then when you get there, what do you do with those two numbers? Subtract. So that leaves you with a 2 and you bring down your 6, right? Then how many times does 13 go into 26? Twice. Then 2 times 13 is 26, right? I subtract, I get 0. Does that mean my answer is 42? No, I know I'm not done because I still got something there. I bring down the 7. 13 doesn't go into 7, so my answer is 0. This is 0, and then my remainder is 7. So when you very, very first learned this, I'm pretty sure, I never taught elementary, but I think you do that, then you put R7, like because you haven't talked about the fraction part of that. But the answer really is 420, and what do I do with that 7? Put it over 13, very good, 7 over 13. And then you have this whole and you have this piece, and technically you're adding those two things together even though there's no addition sign there, right? Okay. If you can do that, you can do polynomial long division, piece of cake. All right? Exact same steps, 99% of them. It's really no big deal. So let's look at what this looks like then. And one thing I do all the time when I do this is I don't leave myself any room to write above this, so make sure you drop down at least a little bit. I'm going to take this x plus 4, and it's going to divide into 3x cubed plus 2x squared minus 37x plus 12. So when you were dividing that 13 into that number, you just had one term, the 13. Here we have two numbers, x plus 4, or two terms, x plus 4. We kind of, at the beginning, we kind of just ignore the 4, right? You're really just trying to see what x does into this stuff here. So when I take x, I want to know how many times does x go into 3x cubed? Or basically, what is 3x cubed divided by x? And if you need to, because I've seen a lot of people do this, go off to the side. I'm looking at this first term, and I just put it over x, right? And then when I do that, that ends up giving me 3x squared, right? Because I'm dividing that out. So since that's a squared term, it goes above this, 3x squared. So if I take 3x cubed, divide it by x, I get 3x squared. It's what goes up here. Then just like I did over here when I got this 4, I do 4 times 13. So I'm going to do 3x squared times x gives me 3x cubed. And then 3x squared times 4 gives me a positive 12x squared. Okay? So even though I ignored the 4 when I figured out that 3x squared, then I do have to multiply it back to both. Then when we got here, over here we subtracted, right? We have to subtract here, and you have to subtract both. So basically just go through and change the signs on each term that you have. These will zero out. 2x squared and negative 10x squared, I'm sorry, negative 12x squared gives me negative 10x squared. Then I bring down my negative 37x, and I start all over. When I divide x into 10x squared, that's going to leave me with a negative 10x. So this gives me negative 10x squared when I multiply it back. And negative 10x times 4 is negative 40x. Since I'm subtracting, I go through and I change the sign on each term so that these zero out, and this gives me a positive 3x and I bring down my 12. Okay. So then x divided into 3x leaves me with 3. So that gives me 3x plus 12. Don't forget to change your signs. These zero out, and so do these. My remainder is 0. So my answer then is what I have up here. My answer is 3x squared minus 10x plus 3. What questions do you have? Anything at all? You can do this. Okay. So let's look at 5. Okay. 5, we're going to take 2x plus 7, and we're going to divide it into 2x cubed plus 5x squared minus 19x minus 42. Okay, so 2x divided into 2x cubed, what would that leave me with? X squared, and I put it above the x squared here. So then I multiply it back, and I'm going to get 2x cubed plus 7x squared. Change the signs. These zero out, and I get negative 2x squared minus 19x when I bring that down. All right? So then when I take 2x divided into negative 2x squared, what's that going to leave me with? Negative x. Okay, very good. Yeah, and it's a negative x, so watch your signs. So then this gives me negative 2x squared minus 7x. I change the signs. These zero out. This becomes negative 12x. Bring down my negative 42. Then not negative 2, but 2x into negative 12x gives me what? Negative 6. Good. I multiply that back, I will get negative 12x minus 42. Change my signs. Those zero out, and so do those, so my remainder is 0. My answer is x squared minus x minus 6. What questions you got? All right, so we're going to do number 6 also, because something else happens in here that I want to make sure that you catch on here. So I'm going to take x squared plus 8, and I'm going to divide it into x to the 4th plus 3x cubed plus 4x squared plus 24x minus 32. That's a long one. All right. So x squared into x to the 4th leaves me with what? X squared, right? So I put it above the x squared term. See how the things are lined up? X squared times x squared is x to the 4th. X squared times 8 is a positive 8x squared. Look at where I put it. I can't put it under the x cubed. I got to put it over there under the x squared so that I can actually subtract things. So then I go in there and I change the signs. Right? These zero out. I have to bring down my 3x cubed because I can't forget about him. And then this gives me a negative 4x squared. And then I still got to bring down the next one, which is a positive 24x. So make sure you're keeping everything lined up. Sometimes there's holes in there, and that's okay. You just got to make sure your stuff stays lined up. All right, so then x squared divided into 3x cubed would leave me with 3x. Good. So then I multiply it back. 3x times x squared is 3x cubed. And then 3x times 8 is a positive 24x. So I've got to line those up correctly. I change the signs. These zero out. I got to bring down my negative 4x squared. These zero out, which is fine, and then I bring down my negative 32. So there's a huge gap right there right now, totally fine. Then x squared into negative 4x squared is a negative 4. So when I multiply it back, I get negative 4x squared minus 32. I change my signs. And then those zero out. So do those. My remainder is 0. And my answer is x squared plus 3x minus 4. What questions do you have? You remember doing this? Not that bad? Okay, good deal. All right, so we're going to skip the next couple, and we're going to jump to number 9, because if you can do number 9, you can do 7 and 8. Our remainders so far have been 0. They're not always 0, okay? So I'm going to take x squared minus x minus 5, and that's going to divide into x to the 4th minus 5x cubed plus x squared plus 20x minus 10. And also, this has 3 terms dividing it into. Totally fine, exact same steps, no big deal. I still just take the first one, x squared, divide it into this first one, which is x to the 4th. That will leave me with x squared, so I put it over the x squared term. Then I multiply it back. X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times negative 5 is negative 5x squared. I go through and change the signs. These zero out. Then I've got negative 4x cubed plus 6x squared. And I bring down the 20x. Okay. Then I do x squared into negative 4x squared. What does that give me? 4x. Wait a minute, what did I do wrong? Oh, you know what I did? This would be cubed, no wonder. I was like, why is that coming out weird? Sorry, let me re-ask this question then. So x squared into negative 4x cubed does give me negative 4x. And I was like, why isn't this working out? But I wrote the right numbers down. So then I multiply it back. Negative 4x times x squared, negative 4x cubed. Negative 4x times x, positive 4x squared. Negative 4x times negative 5, positive 20x. Go in there and change my signs on each term. These zero out. This becomes 2x squared. These zero out, but I still got to bring down my negative 10. X squared into 2x squared leaves me with positive 2. I multiply it back, I'm going to get 2x squared, and this is one reason why we have to leave this gap, because then I have a negative 2x. That's got to go right there. If you want, when it zeroes out, you can put like plus 0x. If that helps you with a placeholder, it doesn't matter. And then 2 times negative 5 is negative 10. I change the signs. These zero out. This leaves me with 2x, and then these zero out. And then I can't divide x squared into 2x. So I have a remainder. Totally fine. My answer looks like this. I take what's up here, x squared minus 4x plus 2. And then just like what we did when it was a number, you take your remainder, which is 2x, and you put it over the divisor, which is x squared minus x minus 5. Now, when it's a number, you just kind of put that fraction there, but because this is an equation or an expression, you have to put a plus sign there. And you always add the remainder, always. Okay. What questions do you have? We good? All right. So we got another thing that can come up besides non-zero remainders. We could have missing powers. Okay. So when you look at number 10, this is a 4th degree polynomial, which means it should have 5 terms in it, but there's only 4. I have x to the 4th, x squared, x, and then my constant term. I'm missing the x cubed term, all right? If something is missing from what's inside, if something's missing from on what's outside the house, we don't care. If something's missing from the inside of the house, you have to put a placeholder. So I put x minus 8 out here. Inside, I'm going to have x to the 4th. Since there is no x cubed term, I have to put plus 0x cubed minus 64x squared plus 9x minus 80. So that didn't change the value of it, it just changed the way it looked, and I have a placeholder for that cubed now. And then the rest is the same. So we'll go through here. X goes into x to the 4th, x cubed times, so I put it above that newly created x cubed term. X cubed times x is x to the 4th. X cubed times negative 8 is negative 8x cubed. Don't forget to change your signs. These zero out, and I get 8x cubed minus 64x squared. Then x into 8x cubed will give me a positive 8x squared. Multiply that back, and I get 8x cubed minus 64x squared. Then I change my signs. These zero out, and these zero out. So since both of them zeroed out, I have to bring down both of my remaining terms. That gives me 9x minus 80. So when I take x and divide it into 9x, I'm left with 9. So I put it above the constant term. Okay, because it's a positive 9. I'm not going to have an x term, which is fine, so I'll leave a space there. And then when I multiply it back, I'm going to get 9x minus 72. I change my signs. Those zero out, and I'm left with negative 8. So even though there's a big space here, and in my final answer, I don't have to put a 0x term in there. I'm just going to cram it all together now. So I get x cubed plus 8x squared plus 9. I always add my remainder plus the numerator of the remainder is a negative 8. Denominator is x minus 8. Can I cancel these negative 8s out? No, you can't. This is your answer. Always add your remainder, always. Okay, because other weird things can happen in there, it'll make your answer wrong. What questions you got?
So there's a missing exponent
in the dividend?
Yeah.
Not always, not necessarily. I think that was kind of a coincidence, but not necessarily always. Good question. And vice versa, like if there isn't a missing one, you could still have a missing one here. It just depends on the answer. Good question. What else you got? All right, so you're going to do number 11 on your own, but you're going to do it in stages. The first thing I want you to do is set it up. So basically what I have in green, you do that for number 11 right here. I'll give you a second to do that. Then we're going to double check that we're all correct before you move on. Once you've got it set up, check yourself with me. If you agree with what I have, then you can go on, and I want you to divide it out, do the whole thing, get your answer in the end. And let me know if you have any questions here if we don't match. We had a missing term in there.
What about x?
I don't care about that. This is a 3rd degree, so 4th, 5th, and whatever, I don't need all those. I just got to start, you start with the highest and go down. When you're done, check yourself with me. Let me know if you have any questions. If not, then we are done.